Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. When we think about the air we breathe, we usually look to the skies or the vast green canopies of the Amazon rainforest. We imagine a world where trees and microscopic ocean plants are the sole guardians of our oxygen. However, there is a much deeper, more ancient rhythm at work beneath our feet. A process that operates on a timescale of millions of years. This is the tectonic clock. Scientists have begun to realize that the long-term stability of oxygen on Earth isn't just a biological miracle, it is a geological one. Specifically, it is the process of plate subduction that acts as the ultimate regulator, ensuring that our planet remains habitable for complex life. To understand this, we first have to look at the delicate balance of the Earth's atmosphere. Oxygen is a highly reactive gas. Left to its own devices, it would quickly disappear from the atmosphere by reacting with rocks and organic matter in a process called oxidation. For oxygen to accumulate to levels high enough to support creatures like us, something must constantly be pumping it into the air, and more importantly, something must be preventing the carbon produced by life from stealing that oxygen back. This is where the movement of the Earth's crust becomes critical. Subduction is the process where one tectonic plate slides beneath another, sinking into the hot mantle below. This might seem like a purely destructive force, but it's actually the heart of Earth's recycling system. As the oceanic plate descends, it carries with it layers of sediment, including carbon-rich organic matter and carbonates. By dragging this carbon deep into the Earth's interior, subduction prevents it from reacting with free oxygen in the atmosphere. In essence, the Earth hides carbon in its mantle, allowing oxygen levels to rise in the atmosphere above. Without this burial mechanism, the oxygen produced by photosynthesis would be almost immediately consumed by the decay of the very organisms that created it. But the tectonic clock does more than just hide carbon. It also provides the fuel for oxygen production. As plates collide and subduct, they create massive mountain ranges. These mountains are immediately subjected to the forces of wind and water. This chemical weathering of continental rocks releases essential nutrients, most notably phosphorus, into the rivers and eventually into the oceans. Phosphorus is the limiting nutrient for life. It's like a super fertilizer for the phytoplankton that produce half of the world's oxygen. When tectonic activity is high, the supply of phosphorus increases, leading to massive blooms of life, which in turn pump more oxygen into the system. This cycle has played out several times in Earth's history, often coinciding with major leaps in evolution. For example, the Great Oxidation Event, and later the Neoproterozoic Oxygenation Event, are closely linked to periods of intense tectonic activity and the formation of supercontinents. Each time the tectonic clock ticked forward, the resulting surge in oxygen provided the energy density required for life to move from simple single-celled organisms to the complex, multicellular animals we see today. Large-brained, high-energy creatures like mammals require an atmosphere rich in oxygen, and that atmosphere is a direct product of the Earth's churning interior. Interestingly, this process also acts as a thermostat. If the Earth gets too hot, weathering increases, pulling carbon dioxide out of the air and cooling the planet. If the planet gets too cold, tectonic volcanic activity eventually releases enough CO2 to warm it back up. This feedback loop, regulated by the speed of plate movements, has kept Earth's climate and oxygen levels within a Goldilocks zone for billions of years. It's a rhythmic, mechanical process that makes our biological existence possible. When we look at other planets, like Mars or Venus, we see worlds where the tectonic clock has stopped or never started. Mars is a one-plate planet. It lacks the recycling power of subduction. Without it, Mars couldn't maintain its atmosphere or regulate its chemistry, eventually becoming a frozen desert. Venus, on the other hand, suffered a runaway greenhouse effect without the cooling mechanisms provided by a tectonic carbon cycle. Earth remains unique because its crust is constantly in motion, grinding, sinking, and renewing itself. So, the next time you take a deep breath of fresh air, remember that you aren't just breathing the product of trees and sunlight. You are breathing the results of a billion-year-old geological engine. The oxygen in your lungs is the signature of a planet that is alive, not just on its surface, but all the way down to its core. We are the children of the tectonic clock, living in a brief, beautiful window of time created by the slow dance of the continents. For more incredible facts like this, don't forget to subscribe and turn on notifications.